Hey folks, welcome back to DIY Buddy Guy. It is midnight on New Year's Eve, and my circulation pump went bad for my radiant in-floor heat. Fortunately, I had a brand new one on the shelf. Yeah, there are a few bucks, but when you need the circulation pump to heat your house or what have you, it's always good to have an extra one on hand. I discovered there was an issue because the breaker was tripped. Went through the process of elimination, testing things with my meter. What's interesting is there is no my meter is not able to detect a short from the hot to the ground on the motor, and there's continuity through the windings. I'm gonna have to get a different meter, a more sensitive one, to see if there's any short in the windings from hot to ground. But either way, the motor keeps tripping the breaker, so I'm going to replace the circulation pump. Typically, these things are designed where you can unbolt the motor basket from the housing and just swap out that part. But as you can see, there's been a little bit of a leak here. When I went to unbolt the motor basket from the pump housing, it started to leak from here, and it's not supposed to. So once I get this off and swapped out, I'm going to tear it apart and show you what's on the inside, and we'll see if we can figure out why this one went bad. But to install a new circulation pump, a couple of things you need to keep in mind. Typically, the bolt pattern on these flanges are the same size. Sometimes the pipe size will differ. This is a 1-inch copper or 1-inch threaded port. The circulation pumps are directional, so you have to observe the direction of your flow, and you also want to install them in a position where the electrical connection box is either on one side, the other, or the top. You never want that on the bottom in case there's a leak. And the manufacturer also recommends that your motor shaft is in a horizontal position. No matter what orientation, you have to keep in mind 3 things: the direction of flow, the horizontal shaft position, and that this box, your electrical connection box, be either on the side or the top. So to change the circulation pump, I have a valve before and after, and I isolated the pump. I'm going to loosen these nuts and bolts, remove the pump, and then install the new one, and I'll show you how I make my wire connections. Okay, so I have my nuts and bolts loose. I only need to remove the ones on the front. I can leave those in place because, as you can see, this side of the flange is notched and open. So if I remove this bolt, the same thing on the bottom here, the pump will slide forward off of the flanges, and I can reinstall the new one the same way. So you can see the bolts on the back. That one just settled down. We'll have to pick that up and put it back in. And there's gaskets. Fortunately, new gaskets came with the new circulation pump. We'll be lining up everything here in just a second. Okay, so to install the new one, I need to pay attention to the direction of flow. I want my fluid to flow down this direction, so it's going to match the arrow. I need to pick up that bolt, slide the flange underneath it without knocking off my gasket, which just presses into the housing. And then this flange, the upper flange, will just slide into place, and then I can reinstall the outer 2 bolts. Okay, so I have the new circulation pump installed. You can't see it, but on the back side here, I observed the flow. I need the water to travel down into my floor. Make sure the gaskets were seated properly, that they weren't all wadded up, and tighten the flange bolts in the front and back and the top and the bottom. I also opened the valves so that water will flow freely. I'm working on my electrical connections, and just want to show you that real quick. First thing you want to do is get to the ground, put your ground wire and your ground screw for safety's sake. If you tighten your screw to the right, you want to wrap your wire in the direction you're tightening it, so when you tighten the screw, it draws the wire in. If you have it the other way, when you tighten the screw, it'll open the wire. You don't want that to happen. So something I neglected to mention earlier, you want to make sure that power is off before you start working on things. I have up here, if you follow this wire, it runs up to a switch for my radiant and floor, and the switch is off. Essentially the power to the entire system is not, but this pump is isolated via the switch that's off. So what I did was, in the process of diagnosing this, I used my meter right here with my test leads. Wanted to make sure that I had power here without the breaker tripping, and I'm going to do what I don't recommend you do: call a qualified electrician, which that is my trade for any of you keyboard warriors. I'm going to turn on the power up here, and this circuit is now hot. It's live, and I want to make sure that that I have the correct voltage here for the pump. The pump is rated at 115 volts, and I want to make sure that I have at least 115 volts here. So what I'm going to do is use my test probes from leads from my meter, touch them to the wires, and my meter says that I have 100 and sorry about the screen on the meter. It's 118.1 volts on 79. So I have the required amount of voltage here, and I was able to turn on the switch without the breaker tripping, which means that the problem was isolated to the pump. And once I get this hooked up and test it, we're going to tear apart the old one, and I'll show you what's inside that bad boy right there. So I have my wires connected. I have the black from my electrical supply connected to the black for the circulation pump, which is a hot wire. The white from the electrical supply connected to the white. The green is connected to the ground screw on the circulation pump. And I have the cover there. I'll be putting that on in just a minute. What I want to do now is turn on the power and make sure that everything works out the way it should. I just heard the pump kick on, and you can watch the temperature gauge start to rise as it's pulling warm water from my boiler loop. Incoming water is 150 through the mixing valve. I have it set for about 90. Yeah, just a little more than 90. And it's warm. It's working the way that it should. So let's get this covered up and tear apart that other pump. So here is the housing from the circulation pump. The water comes in through the middle. The impeller will spin and throw the water to the outside, pushing it that way. I've seen some models where there is a plate across here that is sealed, where the impeller and the shaft comes into a housing that the motor cage will sit over. This one happens to be a different style, where the that plate is actually mounted to the motor housing itself. You see that thin line right there? There are some styles where this plate here, the stainless plate, is fixed to that housing, and then you can remove the entire motor basket and it stays sealed, and just put this right back on. But I guess that's pretty much it.